Hello and welcome to my final project, application of RNN for algorithmic stock trading, done as part of the deep learning course. A token of appreciation to the Professor Georgievic and TAs who organized this course pretty well with a focus on practical aspects of deep learning. Recurrent neural networks that includes RNNs and LSTMs are very popular for predicting patterns in time series-based data. Stock market data, which is naturally time-based, fits perfectly well here. We will explore to see if we can make reasonable predictions for the short-term intraday stock prices. Problem statement. How can we use RNN-based convolution networks to predict stock prices, at least in the short term? This is the question that this project explores by performing various experiments around single versus multiple variables as input into the RNN model. We especially chose one of the popular tech stocks, Microsoft, for single variate analysis. We also wanted to see the effect of tech sector performance on Microsoft, and we chose an ETF, XLK, for this purpose. XLK is an exchange traded fund that has about 72 different holdings. That includes Microsoft, Apple, Facebook, etc. Microsoft is one of the largest holdings of XLK with about 12%. And lastly, we wanted to see if the overall stock market performance as indicated by SPY ETF has any impact on Microsoft price movements. A brief introduction to algorithmic trading that is popular within Wall Street for automating the execution of stock orders. It is a method of executing a large order using automated trading instructions, accounting for variables such as time, price, and volume to send small slices of order into the market over time. Some of the popular strategies include TWAP, VWAP, and POV. Many of them are time slice based strategy, and the primary goal here is to reduce the transaction costs for the execution of the order itself. So any prediction in the near term can help to achieve this goal. Let's talk about the elephant in the room, the data. We used 1-minute resolution stock data for a period of 1 year, downloaded from quantcode.com, a data vendor that sells market data with different time resolutions. We downloaded for about 100 US stocks. That includes Microsoft, and in addition, 2 ETFs that is under consideration for this project, XLK and SPY. Even though the total data downloaded is more than 3 gigabytes, we ended up using only a small portion, 1 year worth of data for the 3 stocks, Microsoft, XLK, and SPY. Here is a raw data sample for Microsoft stock on 2014, January 2nd, for the time interval 9:51 a.m., right after trading hours started. We can see the open and low price, high and close price during this interval. And for this project, we primarily focused on the close price for all of our experimentation. You can also see the volume column there that shows how much of the Microsoft stock traded during that 1-minute interval. An important step in any deep learning methodology is preparing the data itself. We pre-processed the raw data and extracted all the samples for trading hours only. We then performed an inner join between these 3 stocks to address the missing data for some samples. We then augmented the data by calculating 1-minute return and cumulative return. And finally, we wanted to calculate the so-called parameter relative strength index that indicates whether the stock is overbought or oversold based on a given time period. We wanted to make use of RSI during multivariate analysis, which will be described later. And finally, we normalized all the data columns like stock price, column particular, using mean and standard deviation values. This is how data looked after a pre-process stage with augmented columns from XLK and SPY stocks. Besides the close price, we will also use 1 minute return during single variate analysis. Let's see how well these stocks are correlated to one another using 2014 data. We calculated cumulative returns during pre-process stage, and here is the plot that shows the relationship. We can clearly see that Microsoft and XLK are positively correlated by about 0.96 for the most part of the year, and likewise Microsoft and SPY as well. Here is another plot showing 1 minute returns for the three stocks, with Microsoft stock much more volatile than XLK, and XLK in turn more volatile than SPY. The takeaway is individual stocks like Microsoft tend to move larger compared to the indices that represents the whole industry sector or the overall market. The first part of the project focused on single variate analysis, and we performed 3 different experiments. We wanted to see how well an RNN-based model can predict stock prices in the short term, and likewise predict stock 1 minute returns. And lastly, we wanted to explore predicting just the direction of the stock price itself in the near future, whether stock price will simply be up or down as a logistic indicator. And that's the third experiment. The second part of the project focused on the multivariate analysis using both Microsoft and XLK prices as input into RNN in order to predict the Microsoft prices as output for the short term. We did 2 experiments here using 2 different training periods. In one case, we used the 2-month period when Microsoft and XLK prices correlated the most in the 2014 year, and in another case, used the same time period, which is the first 2 months of 2014 that we used during single variate analysis. RNN model that we specifically designed for this project uses 2-month training period and an overlapping test period using the same 2-month period and an additional day outside of training for comparing the performance of the model for short term. The RNN model itself was trained multiple times to predict with different time lags into the future at 1-hour intervals all the way into 6 hours. We saved the training model with weights in the respective files for reload and test later. Finally, we used Atom Optimizer with MSE as the loss function, and also used the same to compare the performance between different experiments. To summarize, RNN model that we designed uses 2 days worth of data, which is 780 samples as number of time steps, with each RNN cell taking either 1 input for single variate or 2 inputs for multivariate analysis. Before we started on the real experiments, we wanted to decide on the optimal value for number of time steps into the RNN model. So we did a quick experiment comparing 5 days worth of data, which is 1950 samples, against 2 days worth of data, 780 samples. And the takeaway is we didn't see any significant difference in the quality of the model as evident from the loss value. The results are presented in the next slide as well. As you can see, the prediction remained the same in both cases. We will now focus on the results from single variate and multivariate RNN analysis. For the first part with single variate, task 1 focused on predicting Microsoft prices with a time lag of different 1-hour intervals into the future. Results are shown here with the actual versus predicted stock price and the corresponding loss value in each case. The takeaway is the model captured the overall trend in the stock price, though it failed to predict accurately the prices at 1-minute intervals. However, this model becomes a base case to compare against the rest of the experiments with single-variate analysis. Continuation of the previous experiment, prediction of stock price with different time lags into the future up to 6 hours shown here. We see that the prediction is getting worse as the prediction window grows. This is expected. We do see that predictions have picked up for the short term up until 60 minutes and overall picked up the long-term patterns. This is the second experiment in single-variate analysis to predict stock returns instead of stock prices. This model performed worse than previous model that predicted stock prices. And this is evident from the normalized loss values shown here. And finally, the last experiment we wanted to explore in the single-variate case is to see if the direction of the stock price movement up or down can be predicted. This model performed much better compared to the previous one that predicted stock returns. Let's move on to the multivariate RNN prediction. We analyze the impact of XLK price on Microsoft prices by inputting this time both Microsoft and XLK prices into RNN model. The first part of the experiment focused on the same time period as the single-variate analysis that we performed previously, and surprisingly, the results are worse now. This is demonstrated by the loss values as shown in the table. And the part of the reason why this is the case is that Microsoft was only modestly correlated to XLK during this time period. The correlation coefficient is about 0.63. Continuing the same experiment, here is the results showing the prediction with different time lags into the future. We see that the prediction is getting worse as the prediction window grows. And in particular, the peaks and valleys have been smoothed out by 360-minute prediction line. Now, last but not least, we repeated the same multivariate experiment, but using a different time period. This time we used the time period where Microsoft and XLK were positively correlated the most for the entire 2014 year. And as expected, the performance came out much better when compared to the previous one with much lower loss in this case. Continuation of the same experiment showing predicted prices with different time lags, 1 hour all the way 6 hours into the future. The model performed better compared to the previous experiment that used different training period. Model also performed better than the single variate analysis that was done in the previous section. Conclusions. So we presented a general pipeline of the data download process, cleaning, wrangling, normalization for single versus multivariate RNN models using 1-minute resolution stock data, trained appropriate RNN models in each case with varying training periods, etc. We performed multiple experiments ranging from prediction of stock price movement up or down in the near future to the prediction of stock prices themselves and returns percentage. And the summary of results is once again presented here. Pros and cons of the model or the technology that we built for stock price prediction It is a simple RNN-based model that demonstrated well the differences between single versus multi variables as input. The model performed reasonably well to predict the stock prices. And finally, the model is easily extendable to have multiple inputs. And the effect was seen when the XLK price was used as well. In terms of cons, predicting stock prices is one of the hardest job out there. It is not an easy one. RNN-based models suffer from amnesia. It cannot capture longer-term patterns satisfactorily, and that's where the much more popular LSTMs can help, and in theory should produce better results for the same problem. And some extensions to the project work. We could do an LSTM-based experiments instead of RNN that we showed here. And we also need to address the problem of overfitting using regularization. And finally, we could have run the model on a test period which is completely outside of the training period. The current one has overlapping test and training period. With this, we conclude our presentation. Thank you again.